right, so let's get into maybe some more positive thoughts, and let's pretend like we have money and we want to invest it. So we're going to talk a little bit more about investing uh, as we have money going forward. So we're going to look at some different options here. I'm going to start with what are called certificate of deposits. Basically, it's like a fancy savings account. You probably have a savings account, whether your parents have opened up a bank account for you, that you shared with, that they share with you, but you probably have a savings account, and a CD is basically a savings account that will give you a little bit better interest than just having it in a regular savings account. So we're going to look at some options here and do some calculations based on what those would give out or pay out for investing our money. And so basically a CD, you're just going to basically give them money and let it set. So a 3-month CD at 0.5%. So notice that is already a percent. That's 0.5%, half a percent of interest over the course of 3 months. You have to have a minimum of 500. So you go in, you deposit 500, and after 3 months, you take out your money and you get some interest, and you get that interest in return. So the bank is using your money, and so now you are the one gaining interest. Okay, so we can make this calculation with that formula again. This formula is the same. In this case, again, N is in years, P is the principal, K again is the compounds per year, but in this case, we're talking about investments. We're just calculating once per year. So that interest is once per year. So in this case, when we set that up with using the formula, we have the 0.5 is the rate. Remember, that is the percent. And then notice here we get 0.25. You take the number of compounds per year, which is 1, times the number of years, which is 3 months. So notice N is in years. So we have to convert this 3 months to years. And so that's where we get the 0.25. We can also use the TVM solver to do the same thing. So again, notice 0.25 is N, because if you take the number of compounds per year, which is 1, times the number of years, which is 3 months is 1 quarter, or 0.25 of a year, 1 times 0.25 is 0.25. The interest rate is 0.5 on that initial investment of 500, and we get $500.62 in return. Woohoo! So we earned 62 cents of interest back from allowing the bank to use our money. Okay. So let's take a look at another one here. We talked about why 0.25, again, because we needed to convert the months into years. So N, the lowercase n, specifically is in years in this case. All right, let's take a look at a couple more. These are on your sheet, so you can kind of fill these out as you go on your note sheet. Here we have a 6-month CD, right? So best 6-month CD. The term is actually 8 months, right? So notice there that they call it 6-month CD, but it's actually 8 months. You have to have $1,000 minimum, and it is 0.8%. So it's a little higher rate because you're allowing them to use your money longer. So it's a little bit higher rate. Again, if we use the TVM solver, N, right? N in this case, so 8 months is 0.6 or 2/3 of a year. So 0.6 repeating, or 0.67, and so on. You could just type in 2/3, 2/3 here, and it would spit out that decimal. The interest rate, the present value, the amount that you're allowing them to borrow from you. And then in return, after that 8 months, this time we get $5.33. $5.33. So they took 1,000 of your dollars. They did whatever they did with it, but they're giving you $5 in interest for using that. So the 1,000 original amount plus the $5.32, 33 cents in interest. Okay, another one here. Try this one out if you haven't yet. See if you can piece together some of the things we're plugging in here. This is a 1-year CD for 12-month term, $500 minimum. So we're going to use that minimum amount. You can pause the video and try this one out if you haven't. All right, you can check your work here. In this case, N is 1. So again, 1 12 months is 1 year, and we're doing this for 1 year. So 0.8 is the rate, and then again 500. This time we end up with 504. So 504, which means we got $4 interest off of this investment. All right, why don't you go ahead and try these two out, see if you can work through those, and we'll check those here when you unpause the video. All right, so that first one, you might have input your calculation like this, with N being 1.5, because it says 18-month CD. So your final amount, $1,012.78. So we earned about $12.78 of interest, but the term is actually 17 months. So if you used 17 months, your N should have actually been 1.416, repeating. So you have slightly less interest gained because you didn't allow them to borrow your money for one more month. So just about the same amount, but slight difference there. So we earned about $12.06 in interest for that CD. And for this one, we're using 6 years. So if you didn't use 6 years, you can recalculate it quick. But for 6 years, 84 months, 6 years, and a 6 interest rate, again, higher due to it being borrowed for a longer period. Present value is 5,000. And then again, your future value is what you're calculating. So your future value in this case is 5,390 and 10 or 11 cents. So we earned $390.11 over the course of that 6 years. So for money just sitting there, great. We did earn a bit of interest there, $390. But obviously, over 6 years, $5,000, that's stuck, that's put away. Typically, when you put money in a CD, you can't really get it back easily. Okay, so that's kind of a fixed amount that you're throwing in there. So those previous examples were all examples of you just put in a fixed amount and that's it. You don't make any contributions. You don't do anything else. You just set it aside, and you can withdraw back out when the time's up. Okay. Better investments would be ones where you could potentially contribute, right? Making contributions to the value of your account would be typically, like a retirement savings fund, that kind of thing, would be those types of accounts that you can make contributions as you go. So not only is interest being calculated, but you can also include more money that interest is being calculated on. One other example of this is stock market, right? So you can invest in the stock market and you can continue to contribute and continue to get interest calculated off that new value. So we're going to take a look at some example of what that might look like in the long term for the stock market. So for the stock market in general, some of you might have known this, depending on how recently you've taken econ. But the average since 1957 to 2018, the average return on investment is 7.96%, which is way higher than what we were just calculating, right? Those percentages we were just using were like 0.5%, 0.8%. This is 7.96%, which is significantly higher. So if we were to use that average over the course of those years, and that fluctuated a bit here and there, but if we were to use that average to kind of think long term, we're going to make some calculations here. And we're going to start with assuming that the stock market grows 8%, which again, 30-year average, that's been, which is the 30-year average. That fluctuates, so that's not a guarantee, but that's been the average. So if we want to invest $1,000 each January, so that means we're going to add in more money every January. We're going to fill in the table, continue filling in the table here to kind of see what happens over the course of the years. So let's take a look at this table, right? First year, we add in $1,000. So the start of the year, the first year, we have $1,000. And then at the end of the year, the 8% interest gets calculated. So we can take 1.08, right? So 1.08 times the amount of the current account to get the new total with the included interest. So this calculation includes that interest. If you just took 1,000 times 0.08, that would just be the interest, right? So if you take 1.08 times 1,000, that gives you the previous amount plus the interest added in. So our new total of the account is $1,080. So the start of year 2 in January, we deposit $1,000 more. And so now our account is $2,080. And then at the end of the year, once again, multiply by 1.08, and we get our new account balance, which now has been calculated based off that $1,000 we put in at the beginning of the year and the 8%. So start of the third year, we add in 1,000 more. We have that total from the previous year. This is the new total at the start of the year. And then at the end of the year, taking into consideration the interest, here's our new total. So take a moment here, and I'm going to have you just calculate the next couple spots. So for years 4, 5, 6, 7, if you want to keep going, fine. Don't waste too much time though. Don't go too far. But try to make a few more calculations, see how you do, and we'll double check those here in just a moment. All right. So if you made a few more of those calculations, great. Hopefully you didn't do the whole thing, because there's a quicker way we can do this, and that is with the TVM solver. So we can make a few of these calculations, demonstrate a few of these calculations here fairly quickly with the TVM solver, rather than sitting here and doing these calculations by hand. So if we take a look here, here's the setup for the TVM solver. If I wanted to calculate for the next year, for year 4, or my total after 4 years, I'm using 8% interest rate. Present value is 0. That's what I'm starting with. Remember, back at the first year, right? Before the first year, before I even input the 1,000, I had 0 in the account. Every year at the beginning, I'm making a payment of 1,000. I'm going to solve for my future value, right? And then interest, we're calculating once per year, right? Once per year at the end of the year. Okay. Now, this right here, our payments are being made at the beginning of the year. We're depositing more money at the beginning, so I need to switch this to begin. And so here's what you should have gotten. If you filled in the value here for year 4, the value you should have gotten is for right here, right? At the end of year 4, right? This value right here, $4,866.60 would be right here, the end of year 4, the December value of year 4. If I wanted to calculate for year 5, just go up, change that to a 5, and now this will give me the future value at the end of 5 years. So the December value of year 5 would be $6,335.93. Okay, so we can use the TVM solver to find those values quicker than having to do that by hand, right? So again, we have a payment of 1,000. Payments each year is 1. Compounds per year is 1. It's calculated at the end of the year. The payments are made at the beginning of the year. And there we go. Just to clarify, we are making payments at the beginning of the year. And so again, we can make those calculations very easily by just changing n to 2, 3, and then eventually to that final amount, 15. Right. So after 15 years of this process at an 8% interest rate, depositing $1,000 every year, so we're adding in 1,000 every year, along with the interest being calculated, we'd end up with $29,324.28. Okay. So just to compare that to a CD, kind of what we did previously. So you have 15,000 in a CD at 1.5%, and that's assuming we could get that rate. Here's what that calculation would look like. $15,000 present value, 1.5 interest rate, 15 years. Here's our total amount. If we did that, a similar thing with the stock market, right? So the $1,000 for 15 years with the 8% rate. Here's where we're at with the stock market after 15 years. So again, a pretty significant difference. But obviously, again, with the stock market, there are definitely risks, certainly risks to consider as things can go up and down and fluctuate. All right, so we're going to take a look at again some more long term, right? So what happens the longer you leave money in there, the longer you do this. So we have right after high school, right? We're going to put $1,000 into the stock market each month, and assuming the stock market continues to grow, right, at an average of 8%, how much would be in there after 30 years, and how much would be in there after 40 years? Again, at any point, pause the video if you need to stop and just catch up on what we're talking about here. But let's go ahead and take a moment and calculate this. So, excuse me. Every year, right? Or sorry, every month we're putting in $100, right? So $100 is the payment, 8% rate. And so think about that. Every month we're putting in $100. So the payments, right? Payments are 12, right? 12 payments per year, which is going to change the compounds to 12 per year as well, right? The capital N, remember capital N, is the payment periods, or sorry, compounding periods. So over the course of 30 years, 30 times 12 would be 360 compounding periods. Okay, so that 360 comes from multiplying the 30, the number of years times the number of compounding periods. Okay. So the future value after 30 years in this format, if we did this every month, would be $150,000. So $150,000 after 30 years of this process. Take a moment and calculate for 40 years. Think about what you need to change, in this on this screen, and make that calculation and see what happens. All right, let's take a look. So after 40 years, right? So that would be 480 periods, right? 480 monthly compounds. The account value is now worth $351,428. Right? So notice what happened. Think about that. From here, this calculation to this calculation was only 10 years, right? This calculation represents 30 years worth of time, but from here to here, that's only 10 years of time. And this amount more than doubled in that 10 years. So that compound interest really starts to build really quick once you have quite a bit of money in there. Over that course of time, it really starts to build in just a few short years after those longer periods. Okay. So for your homework, and more or less for the rest of what we do in this class, you will want your calculator set on end, right? So when we talk about interest is calculated at the end. If there is a calculation with a payment at the beginning, that's when you typically would want that at the beginning. But most often for IB and this classwork, we will have that on the end. So change that back now if you haven't. And then again, this is just a summary of the TVM solver screen. We've done a little bit of work with this already in that previous video. So some of this should be familiar to you. Most of this should be already. The main thing is just capital N. Capital N, the connection there between this and that formula we used a little bit is capital N is the n times the little n times k part. Again, where n is little n is the number of years and k is the number of compounds. Okay. So a couple examples here for you, and then some for you to try on your own, and then a little bit of time for you to start your homework. So a couple examples here just to compare. Again, interest, right? We're talking about interest, and this is at the end. So again, pause the video, and just to wrap your mind around some of the details of these questions, I'm going to kind of work through these, but pause the video as you need to, and rewind and rewatch as you need to. So we have 1,000 invested at 5.4% for 4 years, compounded monthly. So monthly compounds for 4 years, you're going to have to multiply that 12 times 4. right? So capital N, right? Capital N is going to be 12 times 4, and then the rest, $1,000 invested at 5.4% for 4 years. This is what your calculation looks like. Capital N is 48, interest rate, present value, and then again, future value. There you go. For the next one, $25 is invested each month for 4 years at 5.4, compounded monthly. So again, still monthly. This time we're investing $25 each month, so that would be like a payment, right? But we're talking about still interest, and it's calculated at the end. So we're still just calculating interest at the end, but that payment is made each of those months. So this is what that calculation would look like. In this scenario, we end up with about $1,300. And then number 3 is $500 initial investment. Notice in number 2, there was no initial investment. It was just payments each month. $500 initially, 5.4% for 4 years, compounded monthly. In addition, we're making $15 payments each year. And so this is your calculation for that. Okay. So let's take a moment here and look at how much we earned on each investment. So that first one is fairly straightforward. We went up to 1,240. So we earned about $240 on that first or initial plan. Notice that was the plan that we invested the most right up front. For the second plan, let's take a moment here and think about what we actually earned. For 48 months, right, we didn't have any initial investment, right? There was no initial amount, but for 48 months, we deposited $25. So let's take 48 times 25. That's 1,200. So we initially, or over that course of those 4 years, we put $1,200 of our own money in, and the interest then that we got was the total of the account was $1,336. So that only gained us 136 in interest. So about $136 in interest. For that last one, so let's start with, we had $500 initially invested, and then for the 48 months, right, so every month we put in another $15. So of our own money, we put in $1,220. So if we take the 1,421.92 minus our own money, we made about $201.92. So about $201.92 in interest. So if you notice that first one, we made the most interest. And so this is again, this is just one way to demonstrate. The more money you have early on, right? The more initial amount you have, the better off that can be overall. The best thing is the more money you have early on, and the more money you contribute as you go is ideal, right? So notice having $500 early on and then also contributing, pretty soon this amount, it will overtake that first amount pretty quick after that. But it's that first initial huge amount that is really helping that first investment in this case, right, for 4 years. Okay, here's a few more for you to try. Again, try these out. Work with a partner if you want, but try them out and see how you're doing with just these basic TVM solver questions again. All right, so here are your 3 calculation screens and your 3 answers. Again, just be careful, right? All of these are for 10 years, but the compounds, right? So the compounds annually, that just means once per year, right? Compounded annually, once per year. Compounded daily, so 365 times 10 is where you get the 3,650 for the capital N here. And then for 10 years, compounded monthly, where you get the 120 there. Okay, the third option, the third one is a payment, right? So you do have a payment there of 20. So every month you're investing $20. That's included in that calculation then. All right, one or two more here. So for this one, take a moment and read it and see what you can come up with, and we'll talk about these 2 parts here in just a moment. All right, so I am going to save some money. I put $1,500 into an account that gains 1.57% interest per year, compounded monthly. How long does it take to double? So to double would be 3,000. Interest, again, compounds and payments per year is 12. And then capital N, this ends up being 530 years. I don't think I'm going to be around that long. So is it really 530 years though? Remember back to the TVM Solver video, you got to think about the units of this, right? And the units are whatever your compounds or payments per year are. So this is actually monthly period. So 530 months, right? So I need to take that and divide by 12, which gets me 44.17 years. And then I can take that 0.17, 0.1783, and I can multiply that by 12 because that will convert that to months. So this is really 44 years, and I'm going to have to round that up because if I round it down, I wouldn't quite have the account doubled. So I have to wait that until that 3rd month. So 44 years and 3 months, which is still a long time, right? A lot less than 530 years, but still a long time. All right, same scenario as number 7. What interest rate would I need to earn to gain 75% of my original investment? Okay, so that's right there's the tricky part, right? 75% of my original investment. Okay, so a couple ways you could do this. If I wanted to earn 75% of my original investment, that would be, you can see right here, 2,625. And so you might be thinking, okay, how do you get that? Good question. So think about if you take the original investment, 1,500, and 75% of that, 0.75, is 1,125. So you could add that to the original investment, and that total is what I want my total account to be. So in this case, the 2625, that comes from calculating 75% of 1,500 and then adding that in to get that 2625. So the interest rate I would need is 15%, which is huge. It's a huge interest rate to get that to the amount that I need. All right, so these questions, these are the homework questions. You can start working on these, try these out. The answers are here. You can check your answers, check your work, but that is what you can work on for next class period.